Okay, this is Dr. Williamson. I'm going to show you how to do the calculations on Excel and the graphing for one of the trials for the decomposition of hydrogen peroxide lab, which is supposed to be a first order reaction. So it should be here, R equals K H2O2 brackets, right? Except we're going to be plotting natural log of V infinity minus V versus time. And you're just going to trust me that that is a good proxy for the natural log of H2O2 at any point in time equals minus KT plus the natural log of H2O2 original concentration. I'm not going to go into the proof why this is equivalent to that first term right there. I'm not going to go into, you're just going to take my word for it for right now. Now, I did the data entry for this already. You're going to take my word for that. I collected the data every 2 minutes. The burette reading goes to every 0.2 milliliters. So every measurement here ends in 0 or 0.2 or 0.4 or 0.6 or 0.8 or 0.0 again. Okay. Now, the amount of O2 collected is going to be the volume reading minus the initial reading at time t equals 0. Here, the burette reading read 4 milliliters right when I started the experiment before I got any bubbles, but that's not oxygen collected. That's just air that's in the burette. So the volume there is going to be cell B minus that 4 milliliters. So I can just go B 5 minus 4.0 milliliters. Oops, I got to hit the equals sign there for the math to work. Equals. And of course, that's going to give me 0. And I've got to go to one fewer decimal places there. See this term right here? It says decrease decimal. Now, at 2 minutes, the amount of O2 collected will be 5.2 mils minus that 4. And at 4 minutes, the amount of O2 collected will be 8.8 minutes minus that 4 mils. So every one of these, I can do this term minus the constant 4 milliliters. So I can just do here, there, and then I can copy the formula down by hitting Control D, and it copied the formula down. Take a look, this one here. That is here, B6 minus 4 milliliters, 1.2. This one is B20, which is this term, minus 4 milliliters. Now over here, and this is V, the volume of O2 collected. But I have to get V infinity minus V. V infinity is the maximum amount of O2 that you could collect from this experiment. And remember, you're supposed to have heated it up to drive after the 30 minutes. You're supposed to have heated it up to drive off to drive all the hydrogen peroxide into oxygen and then let it cool back down and measure that volume. Well, here I did that. I call that measurement volume heated. That's 34.4. That's not V infinity. V infinity is going to be 34.4 minus this 4. This is the burette reading. V infinity, VINF, is going to be this 34.4 minus the 4.0 milliliters that was air. And we don't count the air. You know, at the beginning of the experiment, it read 4 milliliters because that starting amount was air. So that 30.4 is V infinity. Okay, guys? So over here, V infinity minus V is going to be 34.4 minus this term right here, C5, because it's the amount of O2 collected. So I'm going to go minus C5. Oops, I have to got to put in the equals sign. And it gives me 34.4, one too many decimal places. I'll fix that. Which makes sense. 34.3, wait a minute. It's not, this is supposed to be 30.4. The infinity is 30.4. Oh, wait, Control Z. This is supposed to be 30.4. Fixed it. So now I'm going to go, I'm going to highlight that down, copy the formula down by doing Control D. Now I'm going to check some of the calculations. Let's see here. This is 30.4 minus C14. And that 30.4 minus 21. Yeah, that looks right to me. Okay. Now this is one too many decimal places. Because remember, the burette doesn't go to 2 decimal places. It only goes to 1 decimal place, and it has to end in an even number. So I need to reduce the number of decimal places. Now I need to take the natural log of this. So this is going to be equal to the natural log of D5. D5. Notice when I hit D5, it highlights cell D5. So that's good. And I get 34.4. I can check that out on my calculator, right? 30.4 natural log, 3.414. That looks right. Control down. Good. Now what I want to do is plot. So I highlight those two. This should be the x-axis. This should be the y-axis. Right? Oops. There we go. So now I went to insert. I was at home. Go to insert, charts, scatter. And you guys know me, I want to make it big. Make it big. And you see I got a whole bunch. You know I don't like all this wasted space. I got to get rid of all that wasted space. And I'm going to get rid of this, right? So I'll take care of that in a second. This is too many decimal places because everything, this natural log, if these are all going to 1 decimal place, my natural log should only go to 1 decimal place for right now. So let's see here. I'm not sure how to change the decimal places on there, but the maximum should be 3.5. Let's go to home. I'm not sure how to change the decimal places on that using this. Okay. Oh, and let's see here. This should go to, I don't have to go to 0. I'm going to go to 1.5 for the minimum. 1.5. And then I'm going to go to 30 minutes for my y-axis. Oops. Come on. What am I doing wrong? Axis options. What am I doing wrong? See, tick marks, axis options. There we go. Okay. 30 minutes. And make sure this stays at 0. There we go. We got that. Maybe I want to make these grid lines, major grid lines. Maybe I want to make it 2. That looks a little bit better. I don't know why that's going. Oh, you know what? I bet if I go over here and reduce this number of decimal places, that makes much more sense. Okay. So that, when I changed the number of decimal places here, it changed the number of decimal places here. So here I want to go axes titles. Control Z. I didn't mean to delete the whole axes title. So this is going to be time in minutes. This is going to be natural log V infinity minus V. And I forgot I got to make this bigger. Let's go to home. Let's make that maybe 14 and bold, because I know that old man professor's eyes need this. And he's the one that gives me points. Right? And here I'm going to go first order plot for decomposition of H2O2. And I think for up here, I can go to home, font, subscript, font, subscript. Make this a little bigger, right? Because it's the title. Maybe make it 16. Bold it. And I think I can even, oh no, I don't want to do that. Inside there. And then let me make this bigger like that. Do that. Let me do this. I want to make these as big as possible. You guys see what I'm doing? So I'm making that as big as possible. Still, I need the best fit line. So I'm going to go add trend line. And I'm going to go to a linear trend line. And I'm going to go display equation on chart. If I wanted to, I could set the intercept at whatever value I wanted to by clicking this, but I don't want to do that right now. So there's my best fit line. I'm now going to move this, put it's usually like right about here is good. And then I'm going to make it bigger because I want all of it to be legible for the professor. And then I'm going to separately, one way or another, right? Let's see here, text box. I'm going to go, oop, that's too big. I'll fix that later. Come on, what's going on? Insert text box. I'll put it here. Slope equals negative 0.0. I'll round it to 60. And the units are natural log of anything is unitless, and it's going to be 1 over minutes. So I'm going to write minutes to the -1 power, and I can superscript that. Right? And then I can go, therefore, K equals positive 0.060 minutes to the -1 power. And make sure this isn't all superscripted. I don't want that to be superscripted. Undo superscript, undo that. And then superscript this. Notice the rate constant is always a positive number. Okay. Made that big, make that bold because we want it to be loud and proud. So I'm going to do something like that. Okay, guys. And then, well, this looks like I didn't get all of this to be, looks like I didn't get the L in here. Well, anyway, you guys get it. Okay. So then I'm going to take this picture, copy it, then I'll go over and put it in Microsoft Word, expand it to the size of the page, right? And go from there. I'll see if it shows up here in my share screen. I hope it works. If not, you guys have seen me do that before. So right here, I'm going to go ahead and try and paste it in Microsoft Word. We'll see it if it shows up now. So I'm switching to Microsoft Word now. Maybe you can see it. I'm going to paste it now. I see it now in mine. I go to View, Zoom, 75% so I can zoom out. And then I'm going to expand it to as big of the page as I possibly can. And then now I see it in Microsoft Word, and now it's ready to be printed with my lab. Okay, I hope that helps. And, I hope you guys appreciate the extra effort I'm putting out for you guys, so it helps. Okay, then. See you guys next time.